Today, let's start chapter 3, pair of linear equations in two variables. In class 9, you might have learned about linear equations in two variables. Let's try to recall a few points. Can you give some examples of linear equations in two variables? Look at these examples, children. 2x plus 3y equals to 5. 2x plus 3y equals to 5. 6x minus 3y plus 2 equals to 0. Are they linear equations in two variables? Here you may have a doubt. What is a linear equation? A linear equation is nothing but an equation with the degree 1. An equation with degree 1 is said to be a linear equation. And the examples what we have seen here, 2x plus 3y equals to 5 has a degree 1. It's an equation and it has two variables. So this is a proper example which we can say it as a linear equation in two variables. Similarly, the second one, right? Good. When you look at this one, 6x minus 2y plus 5 is not a linear equation. Why? Why it is not a linear equation? Just think. Yes, the first thing it is 6x minus 2y plus 5 is not an equation first of all. Right now it is degree is 1. It has two variables, but the condition has equation that is equal to comparison. It is not found in this. So it just remains an expression. We can call this as linear expression but not linear equation. Similarly, 6xy plus 5 equals to 8 is also not a linear equation. The reason for this, here this is an equation. Note that here this is an equation, right? It has two variables, maybe that is x and y. But what about the degree? The degree of this term 6xy is 2, right? So this is not a linear equation. This is not a linear equation because the reason degree is not 1. Clear, children? Right. So we can generalize the general form like a linear equation in two variables. Okay, how a linear equation in two variables must be. It is general form in the sense a model. It is everywhere the minimum these are the things to be presented. Ax plus by plus c equal to 0. Ax plus by plus c equals to 0, where a, b, c are real numbers. We are not giving an example, we are generalizing the model of writing a linear equation. So a, b, c are some real numbers, x and y are the variables in this case, right? And the condition a should not be 0, b should not be 0. You know the reason? Yes, a and b should not be 0. If a becomes 0, it looks like only in one variable. If b is 0, I mean the coefficients of the given variables, if they become 0, it will be like in one variable. They won't be representing like two variables, right? Good. So the general form for a linear equation in two variables is ax plus by plus c equals to 0. This is all you have come across in your class 9. Let's move to the next one, right? What is called solution of a linear equation? Solution of a linear equation. Is it clear, children? Is it audible? Yeah. Solution of a linear equation. For example, 2x minus 10 equals to 0. What is the value of x in this case? It's quite easy for you. X equals to 5, right? Yeah. X equals to 5. What is that x equals to 5? That is, when you give x equals to 5, in this equation, the LHS is getting equals to RHS. That is, the equation is getting satisfied. Both are becoming equal. So we can say it's the equation got satisfied. So we consider the 5 as the solution of the given equation. Right? Very good. Is there any other solutions possible? Try to find out. Is there any other solution possible? Yeah. No more solutions possible. Other than 5, we don't have any other value which can make LHS equals to RHS. So here the value 5 is called as solution of this given particular equation, right? Go for this. The next one, look at the next one. X plus y is 10. It's also a linear equation, right? In two variables. Earlier it was with one variable, now it is with two variables. So can you tell me the values for x and y? The pair of values, one for x, one for y, which satisfy the equation. Yes, obviously 5 comma 5, 5 and 5, they really satisfy the equation. One more. Yes, minus 1 and 11. Is it possible? Please check it. Yes, in this case also it is. So here we say 5 and 5, this pair becomes a solution. Even minus 1 and 11 becomes a solution. Let's check for this one. 3 and 8. I took a pair of values, 3 and 8. Yeah, in this case, LHS is not becoming equals to RHS. Hence, the pair x as 3 and y as 8 is not a solution. Is not a solution for x plus y equals to 10. Can you give some more solutions? Are they possible? First of all, try. Yeah, could you get some more solutions? Yes, obviously there will be some more solutions possible. That is, for example, like 6 and 4. Someone says like 1 and 9. At the same time, it can be 9 and 1. Be very clear for which variable you are giving the value. It is right, x equals to 1, y equals to 9. It is possible. X equals to 9, y equals to 1, also possible. But both are not the same, right? Both are solutions, but both are not same, right? Very good. So how many solutions are we getting for this equation in two variables? It is, yeah, it is infinite pairs of solutions possible. Infinite pairs of solutions. Very good. So now we say, we can clear that a linear equation in two variables always has infinite solutions. Infinite solutions. Very good. Right. Let's move to the next one. We have also learned that the graph of a linear equation in two variables is always a straight line. Could you remember that, children? We have done that graphical method representing a linear equation in a graphical method. Yeah, it's always a straight line. Maybe it is parallel to x-axis, parallel to y-axis, intersecting x-axis, intersecting y-axis. Different ways we saw that, right? Very good. So every point, here point I mean coordinates, children. X coordinate, y coordinate. Every point on the line, that is the graph of a linear equation, is a solution, right? That is, whichever point we pick up from the graph of an equation, that is the linear equation, it will be a solution of that equation. And in reverse, that is the other way, every solution of the equation is a point on the line. Whatever the solution, we learned that there are infinite solutions. So whichever point we get as a solution, that will be present on the line, is a point on the line representing the same linear equation, right? So it's very clear, I think, in this point, that is, a point from the line will be a solution for the equation, and a solution for a equation will be lying on the line which was obtained as a graph, right? Fine. Geometrically, what are the possibilities when we consider two lines? Yeah, I'm talking about lines, children. When we consider two lines, that is, in a plane, if you take two lines, if you draw two lines in a plane, that is, what are the possibilities? Yes, we have three different possibilities. Hope you could see clearly. It is case 1. They are intersecting lines, right? Intersecting lines, they have only one common point, right, children? One common point in the sense, the one point which is there for this line is commonly for the other line. This means each of them, they have many points, and this point is a common point. I repeat from the previous part, this point is common point, what I'm saying as common solution, right? This is common solution for both the equations representing that linear equations. Okay, and this, so intersecting lines, we know that they have a common point. In our particular concept, we are saying that two lines, that two equations have one common solution, right? The second possibility, the lines can be parallel, which we say do not meet at any point, right? It means in that case, could you see any common points? Yeah, there are no common points. Indirectly, it's nothing but we are saying there is no common solution possible for those two equations. As each of the line represent one equation, the two equations has no common solution. Third chance. See, it's looking something different, right? It's absolutely like these parallel lines, but when they come close to each other, it is one overlaps the other, right? It is such a lines, pair of lines, we call them coincident lines. Coincident lines come in the same position, right? Coincident lines. Do you find any common points? Yes, very good. Infinitely common points we could see. Infinitely common points. Each and every point present from one line is also a point of the other line. It is, right? As per the solutions, when we say every solution for one line is also a solution for other line. Yes? Are you getting it clearly? It is whichever is a solution for one line, ultimately and automatically it is becoming a solution for other. Yes? Yeah. This is geometrically. It is. Okay. This we can, and I hope you understood to some extent. Yeah. The same thing we are going to check algebraically and graphically in this present chapter, right? This pair of linear equations. Okay. We shall study about solving a pair of linear equation in two variables. How to solve if two equations are given, how to solve them, how to get the solutions or solution for them. Okay, by graphical method, which is already known to you very clearly. It is, right? And algebraic method, that's what the new one. In this algebraic method, we have different methods. In detail, we'll proceed in the next part. Okay, right. Algebraic, along with this, we also deal with algebraic conditions to find number of possible solutions. These conditions, that is from our observations. Actually, I'm giving you ahead. It is, so the conditions, like with learning these conditions, it will help you to decide immediately how many solutions possible for that pair of equations, whether is a solution possible or not, or if so possible, how many solutions possible. That can be noted. That's what we have, algebraic conditions. Okay, only to know how many solutions, but not what are the solutions. Okay, for knowing what are the solutions, we go again like this: solving methods, graphical method, and algebraic method, right? And the end of the chapter, we are going to have some application of linear equations into two variables, that is regarding this chapter, in solving simple problems from your day-to-day life. It is, okay, it has a lot of importance in our day-to-day life, children. Okay, right. Shall we go into the chapter? Till now what we discussed, it's your previous class knowledge. It is, which is connected to the present chapter. Okay, right. Let's move to the chapter very clearly. Yes. We discussed that a linear equation will be of which way, children? That is the general form. Ax plus by plus c equals to 0. Very good. Now, we are dealing for a pair of linear equations. A pair of linear equations. That is two linear equations. Right? Right? Very good. So, a1x plus b1y plus c1 equals to 0. a1, it is indicating a number. b1 a number. c1 a number, a real number. Right, as we are talking about two equations, I took the option like a1, b1, c1. They are the numerical values in the first linear equation. And a2x plus b2y plus c2 equals to 0. that is A2, B2 and C2, they are the numerical values in this second equation. Just to indicate equation 1 as 1 A1, B1, C1, and for equation 2 easy consideration A2, B2 and C2. Right? For this pair of linear equations, we are going to see the different possibilities in comparison about the ratios of the coefficients. Ratios of coefficient. That's what I spoke earlier. That is algebraic conditions. That's okay. Algebraic conditions. We are going to see the algebraic conditions right now. Okay. Fine. If A1 by A2 is not equals to B1 by B2. What is it, A1 and A2? They are the coefficients of x from each of the equation. B1 and B2 coefficients of y in each of the equations. Let's take the two individual ratios. If they are not same, if the two ratios are not same, then that pair of linear equations have only one common solution, children. Right? It is. So, just ratio we can find out very easily. These ratios will help us now to decide whether if the ratio comes like this, both of them not equal, then we can confirm very clearly they have only one common solution. That's nothing but when you do the graph for each of them, they are going to intersect. That pair of lines, they are going to intersect, and we are going to get them like intersecting lines. Is it clear? Right. The same way, if the ratios of x coefficients, y coefficient and constants, C1 and C2, they are constants. If all these three ratios are equal for that pair of equations, then that pair of equations have infinite solutions. They have infinite solutions. Is it clear, children? It is all the three ratios must be equal. It's not that first one is equal to second one is equal to third one. It is, we have written here all the three. A1 is equal to B1, A1 by A2 is equals to B1 by B2, B1 by B2 is equals to C1 by C2. Ultimately, A1 by A2 is also equals to C1 by C2. Right? All the three ratios are equal. We say they have infinite solutions. That is, one solution which you consider for one equation is also a solution for the other one. When we draw a graph for this given pair of equations, we can see one line gets overlapped with the other. That overlap, we should not use the word overlapped all the case. That is about coincident lines. They becomes coincident lines. Clear? Case 3. If it is A1 by A2 and B1 by B2, both those two ratios are equal, and that none of them are equals to C1 by C2. Neither of them are equals to C1 by C2, that is constants ratio. Okay, children? And this